All right, this is Mrs. Slauson. This is 7.3. We are going to be solving rational expressions. So what we're going to do is kind of go back and take a look back at how we've solved so far. And this is also good practice for our final mile marker. So I'm going to go through these problems and then we'll get into the new stuff. So in your final mile marker, you will be asked to solve. So far in Algebra 2, we've solved problems similar to the ones below in our table. So kind of just looking at the different ones in the first equation, if you notice with the 3 and the x plus 2 minus 7, compared to the problem below, the problem above has one type of x and the problem below has more than one type of x. So if there's just one type of x, our goal is to get that x by itself. So that's where we're going to start. So the first thing I'm going to do is distribute my 3 just to get rid of it. Or, sorry, to get rid of the parentheses. So actually I'm going to put the work over here. And from there, I'm going to combine my like terms. I'm going to combine the 6 and the negative 7. So now I have 3x minus 1 equaling 11. And now to get x by itself, I'm just going to move the 3 and the 1 over. So I'm going to start by adding the 1. So now I have 3x equaling 12. And then I'm going to move the 3 by dividing. So when I'm done, I have x equals 4. So in this problem, the method I used was I just got x by itself. And basically, I worked backwards in my order of operations when I do that. Okay, so in the next problem, when I have more than one type of x, my first job is to try to factor it. But I can't factor until I'm in standard form. So that means highest power cubed squared first power to the constant. So I'm going to have to move that 48 over by adding it to the left side. So when I'm ready to factor, I'm going to have x cubed plus negative 12x squared plus negative 4x plus 48. And now it equals 0. And with more than one type of x and with these 4 terms, now that I'm ready to graph, let's see, why won't that work? What I do is I group them with 4 terms. So I'm going to start by grouping. And when I group, I'm going to look at the first set of parentheses. And I'm going to look to see what I can take out of both of those terms. So I can take out an x squared, and then I'm left with x plus negative 12. And then when I go to factor my second set of parentheses, I need another x plus negative 12. They are matching. And that means I will have to take a certain number out. So what times x gives me this negative 4x up here? That would be the negative 4. And then I can make my 2 sets of factors, the x squared minus 4, those are the things outside of the parentheses, and the x plus negative 12. Now when we did this in our mile marker, the direction said to factor completely, so I would actually take that x squared plus negative 4, and if you think about it, it's just x squared minus 4, and make it x plus 2 and x minus 2. It's a difference of squares. And now what I have to do is just go through and see what's going to make all of my factors 0. So my answers are going to be over here, negative 2, 2, and 12. So the strategy that I used is I had to make sure that it equaled 0, and in standard form, and from there, I factored. Okay, and you do have that green page that I gave you that just kind of reviews all the different types of factoring. All right, moving on to the next problem. When I look at it, I also just have one type of x. It's inside a square root, so I'm going to go through those same steps that I did up here in my first problem. And my goal is to work backwards in the order of operations so that I can get that x by itself. So the first thing I'm going to do is move the 6 over. So on the left side, I still have my square root. And on the right side, I now have 7. And now I can't get into that square root until the square root's gone. So to undo a square root, what I shall be doing is squaring both sides. So I'm going to square the left side and the right side. So squaring the left side just gives me 10x plus 9 because the square and the square root cancel each other out. And squaring the 7, I'll get 49. And now to get x by itself, I'm going to keep working to get x by itself. So I'm kind of starting over. I'll move my addition subtraction. I'll move the 9 over. That gives me 40. And then I'll divide by 10 and I get 4. Now, just a reminder, in certain problems, you have what are known as extraneous solutions. And it's just those areas, where you pick numbers for x and you plug them back in. They don't always work. And square roots are a situation where you don't always get numbers that work. For instance, you can't take the square root of a negative number. So to make sure that this answer is not extraneous, I would just plug the 4 back in to my equation. And when I do that inside the square root, I'd get 40. And then 40 plus 9, I would be taking the square root of 49, which is 7. And 7 take away 6 is indeed 1. So that's not an extraneous solution. But again, those areas where you have to worry about extraneous solutions are going to be, first of all, with radicals, with square roots, fourth roots, fifth roots. Moving on to the next one. This was our chapter 6. So again, we kind of have, we had two situations where exponents equal exponents and exponents equal numbers. So here, it's an exponent equal a number. So we're still going to work to get x by itself. So we want to work backwards in our order of operations, but to get rid of an exponent, remember, you'll have to use a log. So kind of putting that one in there. All right. So what I'm going to do first is to get the exponent alone, the base in the exponent. So the base in the exponent is this. So I'm going to have to move the 3 and the 7. So I'm going to add the 7 first. And that's going to give me 21. And then I'm going to divide by 3. And that's going to give me 7. And now the only way to get to x is to turn it into a log. So this is where we talked about making that big L. So I'm going to make log e, which is just ln, of 7 equals x. And then you would get your calculators out, type in ln7, and I don't have a calculator here because you guys are actually taking your ACT, so whatever the log of 7 is, oh, hold on, maybe I have a calculator. I have a little one. Hold on. The log, it's 1.946 if you want a decimal answer. Okay. All right, in the next problem, again, I just have one type of x, and when we had logs, we had log equaling log problems, but then log equaling numbers, and that's the situation. So again, what I'm going to do is just work to get that x by itself. So, I got to get it so it's just the log, so I'll move that stuff, and again, the only way to get to rid of a log is to turn it to an exponent. Now, this is all part of the log, and I know that because of the parentheses. So I'll be moving the 3 and the other 2. So I'm going to start by moving the 2. I'll subtract it. That's going to give me 18. And then I'm going to divide by 3. And that's going to give me 6. And now what I'm ready to do is turn it into an exponent. Now this log needs a base to do that. And when you don't see it with the word log, it's a 10. So now I'm going to turn it into an exponent. And I'm going to do that by making my e. So 10 to the 6th power equals x plus 2. And 10 to the 6th power is just a 1 with 6 zeros behind it. And then now to get x by itself, I'll just subtract the 2. So you had 1,000,000. So when you take 2 away, you have 999,998. So that's kind of the gist of the front side and how you solve. So now what we're going to do is venture into the last part of solving for the year, and it's with rational expressions. Now, there's two ways you can go about it. There's, this situation where you have a fraction equaling a fraction like these. And then if you go to the next page, you have a couple fractions equaling another fraction. In the end, the method I'm going to show you here would also work for here. And it actually might save you a little bit of time, but I just want to show you this method because when you do have a fraction equaling a fraction, and it doesn't even have to be anything this complicated, you want to think that or understand that you can do cross products. So here we go. So the first thing, you only use this when it's a fraction equaling a fraction. So before I do anything else, I'm going to identify my domain, or my excluded values, also known as extraneous solutions. And so I need to look at these denominators and decide what would I never pick. So starting in my first fraction, the one on the left, I can see pretty easily here that I would never pick 3. When I go to the other one, if you don't see it, what would make it 0? Again, just set it equal to 0. I'm going to add the 27. And then I would just take the square root of 27. So again, square roots are positive and negative versions. This is fine to write your answer, but we did talk in previous chapters that you can break that down into the square root of 9 and the square root of 3. And it would be better to say 3 with square root of 3. So that's what I'm going to put up here. Positive and the negative version of this. Okay, so there's 3 things I wouldn't pick. All right, if you don't have that written down, write it down or pause. Remember, you can always go a little bit slower. So what I'm going to do now is I'm going to start the actual solving. So to actually solve, I will be using cross products. So I'm going to take -1, times the x squared minus 27. And then I'm going to take x minus 3. That should equal, x minus 3 times x minus 4. And notice I'm wrapping it in parentheses. So first I'm just going to get this cleaned up. I'm going to get rid of the parentheses. I'm going to start by distributing my -1. And then this is FOIL, neighbors meeting neighbors. It's just the distributive property. So I'm going to get x squared. And then here I'm going to get a -4x, but here I'm going to get a -3x. And when I put those together, I get -7x or -7x. So I'm just going to kind of jump to that step. And then when I have these neighbors meet, I get a +12. So now when I look, I have more than one type of x. It is similar back to this problem. And when you have this one here, when you have more than one type of x, your goal is to factor. But again, I want it to go into this side to equal 0 and to be in standard form. And to make this just a little bit easier, I'd like my leading term, the number that starts it all off, to be positive. So I'm going to be moving this to join this, and that gives me 2x squared. And I'm going to be moving the 27 over by subtracting it with the 12. So when I'm ready, I'm going to have 2x squared minus 7x minus 15. It's in standard form now. It's equaling 0, highest power to lowest power. And I'm going to have to factor. Quick note, this is not going to be easy factoring because of that. So let's make our x. There's -30 x squared. Here's -7x. So what are my factors that would work? They would be -10x and 3x. So now I just rewrite it. Remember, this is not easy factoring. So I'm going to rewrite 2x squared. -7x is going to be replaced by the -10x and 3x. So I still have the same problem. It's still 2x squared, -7x, and -15. But now with 4 terms, I'm going to group them. So, and take my GCF out. So the first set of parentheses, I have a 2x. And then I'm left with x plus -5, which, remember, that's what the next set of parentheses need to be. And then that would force me to take something out. So what times x gives me 3x? That would be a 3. And then my factors are 2x plus 3, these things on the outside, and then the matching set just once, though. Okay? And now what's going to make them equal 0? Well, this one's very easy to see. I would not pick 5. And the other one, not too difficult to see, but if you don't see it, you set it equal to 0. I'd subtract the 3 first. And when I'm done, I get -3/2. So these are my answers. Now with these answers, you just want to make sure that your answers are not part of your domain and excluded values up here. And they're not. So these answers are good to go. They are not extraneous solutions, and I can accept those as my final answers. All right, we're going to go to the next one.